Good evening to one and all. Today's topic is about new capacitive pressure sensor, that is mercury droplet capacitive sensor. The recently introduced mercury droplet capacitive pressure sensor is having a change in capacitance of approximately 6.73 microfarad over a range of 0.0 to 3 kPa. The sensitivity of this type of sensor is also 2.24 microfarad per kilopascal kilopascal, which is substantially higher than that of other type of capacitive pressure sensor. So new capacitive pressure sensor is having a high sensitivity. This is the more advantage of this type of sensor. And as you see this diagram, let us explain about this diagram. Okay. And the basic concept of this new sensor is to a mechanically deform a drop of mercury that is separated from the aluminum electrode with a very thin layer of a dielectric medium. This is the dielectric medium, as you see, so as to form a parallel plate capacitor where the electrode area is variably to a high degree. Okay, the principle of new device therefore is to create a capacitor with a variable electrode rather than a variable inter-electrode spacing as commonly done in other devices. Okay. Next, the four important parameters of this type of sensor is of sensitivity, linearity, pressure hysteresis, and temperature hysteresis. Okay, these are the four important parameters. In this we will study further later. Okay. Next, here the sensitivity is substantially higher than that of other capacitive pressure sensor. This is the most important advantage of this sensor, and hysteresis error is also substantially lower than that of other sensor. And the major drawback of this type of sensor is that it is having a maximum temperature related error is slightly worse than that of other capacitive pressure sensor. Okay. But still it is better than that of piezoelectric sensors, piezoresistive sensors. Okay. Then this is the comparison table between three most important type of pressure sensor. See, this is the piezoresistive pressure sensor, capacitive pressure sensor, and new capacitive pressure sensor. Okay. See, in this as you observe in the table, here the sensitivity of the new sensor is more than that of other capacitive pressure sensors or piezoresistive pressure sensor. See, it is having a 2.24 microfarad per kPa. Okay, so we prefer this new type of capacitive pressure sensor, that is mercury droplet new capacitive pressure sensor. As you move on, this note down this picture, as it is important for this type of this type of sensor. That is, it is a mechanical structure of the sensor. Now I will explain about this mechanical structure of the sensor. The mercury droplet. See, this is the mercury droplet. Okay, this is the mercury droplet. It should have 3 mm diameter and 1 mm thick layer of a ceramic ceramic material which is having a high dielectric constant. Okay, then the mercury droplet should consist in between of compression disc or aluminum disc that serves as a compression mechanism. The mercury droplet is in between the compression disc and the ceramic dielectric layer. Okay, here see here the compression disc in turn acted upon by means of a corrugated stainless steel. Upon the compression disc there is a corrugated diaphragm, as you see in the figure. The compression disc is given a slight curvature as shown in the figure. Such a spacing between the disc and the ceramic layer is exactly 3 mm at the center. In the center it should be exactly 3 mm space between ceramic dielectric layer and the compression disk. Okay, then move on, but less than 3 mm elsewhere. Okay, in this manner the mercury drop will be forced to the center each time the stainless steel diaphragm retracts. Diaphragm held in the place by means of thin aluminum ring. See here, it is placed by means of thin aluminum ring, as you see in the figure. Okay, next, since the air that surrounds the mercury droplet must be allowed to exit from the sensor. To exit from the sensor, the outlet is provided, that is pressure. As you see, the entire assembly is mounted inside the open cavity, that is it is made up of a 24 pin IC chip. To go the air out, to escape the air from the IC chip or a sensor, the pressure relief conduit is drilled in the IC package. Here this is a drilled one. Pressure relief conduit is drilled in the IC package, as you see in the figure. Then here there are the most important four types of parameters, that is sensitivity, linearity, and temperature restriction and pressure restriction, as you discussed later. This is the new capacitive pressure sensor. Thank you one and all.